Welcome back to Nature of Code in Rust with GGEZ. This episode, we're going to go over example I.5, Introduction.5, Perlin Noise Walker. So in this chapter, we talk about Perlin noise and what that really is. It looks like it's a very smooth version of a random noise. So basically, the next iteration, the next random number is going to be related to the previous random number. We can actually see this in an example up above here, where we have Perlin noise that generates maybe what looks like a mountain range or something like that. And often Perlin noise, from what I understand, is often used in terrain generation or a lot of other sort of randomly generated things. This is what like just true random looks like, and this is what Perlin noise looks like. So in this example, we're going to be creating a random walker. So I played around a little bit with Perlin noise to try to find a library that works in Rust, because Rand does not have Perlin noise. And I found one. It's called Noise, nicely enough. So I went ahead and add that in to our cargo.toml. And then I'm also going to be starting to use the air crate, because I found that it's actually really nice for, like, I can just come in here and do a result, air result, and turn that, question mark U, and then return okay like this. Everything still works exactly as expected. I don't need this game result here anymore. I can even come into our main.library, and if I wanted to change this, instead of the game result self, this will be a result, which is an error result, self. This all stays the same. I can still use question mark. These need to be game results because that's what the trait says it's going to return. But this way I can return either my own stuff or the GGEZ game results, and it'll be fine because they both implement error if necessary. Okay, so let's say we want to draw a random walker and we want to like change the noise. Well, if I want to do like the random walker previously, well, let's go into like what they have in their example code, which is right down here. They're using a class walker with some steps. So I'm going to re-implement this in Rust. So I'm going to go ahead and create a new file. I'm going to call this walker.rs. Public struct walker. Let's come back into the main library and mod it. All right, so that'll allow us to start taking in things here. So right off to begin, we have a float x and a y. So we're going to have an x, which is an F32, and a y, which is an F32. Then they have this float tx and ty, and this is going to be the offset for the noise function. So I think I actually want to, I might want to make these like points in their own right, or yeah, let's do, okay, so float tx ty. Let's make this a, I want to change the name here. Instead of tx and ty, maybe like the noise x. And this, so these have to be F64. And that's just how the library that we're working with is. They have to be F64s. There is no F32 version of it. So noise y is an F64. Okay. Then, okay, we have then our constructor. So impl walker. Now in new, what? Oh, we're just setting this to be. Oh, it's not setting. Oh, it's gonna start. So it's gonna start based upon where the x and y just wants to be. Okay, so that's simple enough. We're gonna return a new self. So we're gonna have a let x is. We can have you be 0. y is 0, noise x is, you can also have this start at 0, 0. I have noticed that when we started at 0, 0, it's actually, it's interesting because it starts at like, it starts at, what is it called? 0, 0, like actually 0, 0 in this library. That noise y is also 0, 0. And then we're going to return a self with x, y, noise x, and noise y. All right, so that gives us there. Then we're also going to have this step function. And I don't think we need to return anything here, but we're going to need to take in this this Perlin noise. So I'm going to actually say we're going to have our noise function, and that's going to be a type Perlin. I probably don't want to take ownership of it here. Probably a reference to it is good enough, and then we'll have noise be owned by the main state. Okay, so then the book shows that we're going to use this map function that this map function that is owned by that processing has, and P5JS. So I went looking for it. Let me find copy permalink. There, should be able to get it over here. I went and looked up map inside of P5JS to sort of see what the algorithm is for this, because this is take a number and then map it to a new value based upon constraints. So for example, the noise function is going to give us a number between -1 and 1. And so we want to turn that into a number between 0 and the entire width of the screen or the height of the screen. This algorithm does that for us. So we're going to take our original number, we're going to subtract from the current minimum, do this entire dividing thing. I just went ahead and looked this up instead of trying to like do the full figure it out on my own. And I'm just going to copy this in myself. Now, let's see. If I want to create like a library function in here, well, we're going to do a utilities. And let's actually come into here and we'll do a mod utilities. All right, so pub function. We're going to call this map. And we need to take in the, so what is this? This is going to be and so just copying exactly what they have here. Here, I'll just copy everything that they have here. And then we'll convert it over. So this is JavaScript, so obviously not super happy. So we're going to do a pub function. We have n. This is going to be an f. We're going to just make this an f32. We could potentially make these generics too, so they can work with any number. And in fact, we're going to be getting an f64, but I think I want to convert it to an f32 and then constrain it, because our starts and stops are going to be based upon f32s. So that should be fine. So 32, stop 1 is an f32. Start 2 is an f32, stop 2 is an f32. And there's this extra logic for this within bounds. I'm not going to worry about that. I'm going to leave that the same. So we don't need you. Okay, so we have this const new val. I'm just going to remove that. We're going to return. So our number minus start. So the minimum, that the result of that divided by the initial max minus the initial min times the target max minus the target minimum plus the target minimum. And then I'm going to remove all of you. And return you. Okay, so when we need that, there's going to be map. And what are you upset about? F32 expected. Oh, we need to tell you what to return, which is F32. All right, so now we can actually use this. So we're going to head back over into Walker. So for step, this has like x equals and then map and then transfer, do this entire noise thing. So it's a little bit, we can definitely do that. What I'm seeing here though is that we need also the width, like the screen width, which is an F32, screen height, which is an F32. Okay, so I think we have enough to do this now. So we're going to do self.x. You're going to be equal to, we're going to map. Okay, so our number is going to be this noise dot get, and then we have to give it this point. So the point is an array of 2 items, which is going to be our self.noise, noise x, self.noise y. Now this is going to give us, yeah, we have to do it as a 2 items here too, which is really interesting. Okay, so I kind of want our noise x. Let's actually make this, we can make this a full array also of, this is going to be a F64 2. You're also an F64 2. Wait, no, I want to put that up here. We're going to set you off to be 0.0s and 0.0. So you're going to start exactly the same, but we're going to increment you based upon some arbitrary number that we want to. Okay, so now I can just say for x, this is going to be self.noise x. Okay, so that should be good for you. What are you upset about? Oh, then we need to convert this as an F32. So that gives us good there. Now our start 1, this is going to be the minimum. We know it's negative 1.0, and the maximum is 1.0. Where we want to start is 0.0, and the entire, this is x, so the screen width. And that should give us our x. Let's do self.y is map. We're going to do our noise get self.noise y. F32. Okay, then this entire thing again. So it's between negative 1.0, 1.0. Our start 2 is going to be 0.0, and then screen height. And then before we end, we have to increment those the noise x and the noise y by some arbitrary amount, hopefully small enough. If it's too big of a number, it will feel really random, and if it's really nice and small, then it will look good. Okay, so with that, let's go ahead and do a, let's see, what is this? Self.noise x. Let's do position 0, and I'm going to plus equals 0.01. Self.noise y of position 1 plus equals 0.01. I need them to be different numbers. Otherwise, they're going to just move to get, the X and Y will be exactly the same. This way, it's different numbers across the random graph that is Perlin noise. And the book has an excellent description of what Perlin noise actually is behind the scenes. Screen height, why are you saying you're not used? Because I just hadn't saved it yet. All right, perfect. So that updates you. Now, if I want to draw you out, let's go a pub function draw. I don't think I need, we'll just do a self. We know we need a context. And we're going to return a result. And this can be the error result. So we're going to end with this okay. And we're going to do a graphics draw. Pass the context. Now we need some kind of mesh. Like whatever we're going to, like we have to create the mesh right here. So that our mesh is going to be equal to, we have the location. So this should be, it should be fairly simple. So let's do, we can do a circle, which is the way they sort of describe it here. We can, I don't want to create like a whole bunch of meshes based upon the circles. Actually, you know what? This will be easy. We'll create a mesh here. So mesh, its type is mesh. Now this does mean that we need a context here in new. And we're going to return a result with self. So you're going to have to be an okay. Wrap you in parentheses. Okay, so let's do our mesh builder. New. We're going to do a circle. Okay, so for our draw mode. Let's fill the point of where this is going to be. It's going to be at 0.0. The radius of where we want to put this. Let's make this like a, let's do it like a 5.0. They're using a fairly big circle in their example. Tolerance 0.1 to make it an actual circle, and we'll just go ahead and make this white. Then we'll build you. And in the context, and then we can use question mark. I'm kind of surprised that didn't auto. Oh, I guess I have an error down here, so it doesn't want to continue helping me out with this. All right, so if I want to have like a whole bunch of like draw this circle around and then have it sort of, well, let's have it just sort of move around on its own, and we're not going to see the trail like we do. Well, in the book itself, it shows sort of like a kind of trail. In the example, does it show the trail? I don't remember anymore. No, it just sort of moves like this. So ours will be exactly like that. We're going to do a reference to self.mesh. And then we're going to have our draw param. And I have a destination, which is going to be the self.x, self.y. All right, I think that's everything that we need. So we're going to come back into the main library. We need to store the walker here. So a walker is a type walker. In new, we have this context. We're going to need it. So we can create our walker equals walker. New, pass it that context, then store the walker away. In update, we're going to call step. So self.walker.step. All right, so we need to pass in this Perlin noise, which means we need to store that away too. So we have noise, which is a Perlin. Let noise equals Perlin new. And then here, this will be a reference to self.noise. Okay, Then we need this screen width and screen height. Also easy enough to get. So let screen width, screen height is equal to graphics, drawable size, pass it in the context. And then we can question mark you. Do we need to do that? No, step doesn't return anything, so just like that. All right, we should be fine, good to go here. And then the final thing is draw. So we're gonna do a self.walker.draw, pass it in that context, and we can question mark you. And let's see. Oh, we do have an error. Couldn't convert to a game result. That is true. This couldn't convert the error to a game result error. Now we know that this is a so I probably have to unwrap here. Which is, I mean, it's fine. It means I have less unwraps because I have only one type of error for the most part until this point. So let's go ahead and run this and see what it looks like. And we have our circle moving around the screen quite a bit. That's pretty awesome. I'm going to constrain the speed to 60 frames per second. The way we do that is up here in update. I can do a while loop. So while timer check update time, hand it the context, and then our target frames per second, we'll just do 60. And that should be enough to constrain this. It's only going to run update once every 60 frames per second, which is once every 16 milliseconds, I think, 16.66, which will slow that down considerably. We can also come into Walker and make the size just a little bit bigger. So let's maybe make you like 25. It's a little bit slower, but now we have our circle that's sort of moving around in this very very smooth random way. And that is example I.5 Perlin noise walker. I'll see you in the next video. Thanks. Bye.